Okay, so today we're going to talk about systems of equations with three variables and thus three equations. So you have solved systems with two variables and two equations. And remember that of those equations, the two equations yield an intersection of two lines, and that is the solution. So this can be generalized to as many variables as we want. So if I want three variables, I must have three equations. Okay. If I want seven variables, I have to have seven equations. Now, you can negotiate with Mr. Klein, but you can probably talk him into not making you do seven variables. But make sure you get the three down. So there are two ways to solve this, and there's a method that uses elimination, but we're going to start with the method of substitution here. Okay? So choose an equation. First thing we're going to do is choose an equation we're going to solve for x. Okay? So I'm going to take my middle equation because that looks like the easiest one to do this for. And I'm going to take it, I will subtract from 5y from both sides to solve for x, giving me x equals 9 minus 5y. Okay? I will then substitute x into both equations 1 and 3 to get rid of the variable x entirely. So that's 2, 9 minus 5y plus 3y minus 2z equals -1. And for z, minus 5, 9 minus 5y equals 4. So I'm just going to simplify these. For z, minus 45 plus 25y equals 4. And 18 minus 10y plus 3y minus 2z equals -1. So I'll move the 18 to the other side. And I'll get -7y minus 2z equals -19. And over here, I'll add 45 to both sides. Giving me 25y, I'm changing the order, minus 4z equals 49. At this point, I guess you could do substitution, or I would prefer to do elimination. On these two equations, and I've got a minus 4z and a minus 2z, so I'm going to multiply that minus 2z by -2, giving me 14y plus 4z. Oh, I made them. Nope, I don't want it to be -y. -2. I want it to be +2. I made a mistake when I changed my order. Equals -19. So this would be the 4z was positive here. So I'm going to bring these together, and I'm going to do elimination. Oh, this should be still -4z. I made a mistake. Okay, 2, yes, that is better. Equals -19. And this gives me 11y equals 30. Nope. I am not doing so well on my multiplying. Okay, going back to this equation, I got distracted by the fact that I screwed up the sign. 2 times negative 7y is negative 14. 2 times negative 2z is negative 4z. 2 times negative 19 is negative 38. So let's fix my equation. Negative 14y, the 4z's cancel out. 49 minus 38 is 11. So I can now divide both sides by 11, and I get y equals 1. Now I got to start going through and solving for z. I think I'm going to use this equation because it's positive. 25 times 1. Oops. And that's plus 4z equals 49. So I'm substituting the 1 in for y. I'm choosing an equation with only two unknowns. I could have done the negative 7y minus 2z equals negative 19 as well, or the negative 14y minus 4z equals negative 38. I just thought this one was easier to choose. The 25 times 1 is 25, so I'm going to subtract 25 from both sides. I get 4z equals 24. And when I divide that by 4, I get z equals 6. I now need an equation with x in it. Oh, I like this one up here. X plus 5y, which y happens to be 1, equals 9. So x plus 5 times plug in 1 equals 9. 5 times 1 is 5, so I'll subtract 5 from both sides. X equals 4. My answer is then x equals 4, 4, 1, 6. This is what we call an ordered triple. Instead of an ordered pair, it's x, y, z. Okay, the point of intersection of these three is 4, 1, 6. And these are actually planes. I'll show them to you. Actually, I'll show them. Hold on. So this is what they kind of look like in 3D space. We've got three planes, which is like surfaces of paper or flat surfaces cutting through space, and they intersect at a single point. This is one of the other ones. You can kind of spin it around. It looks like it's somewhere in here for that particular one. 3D graphing is a little hard to visualize in two-dimensional space. Okay, we're going to get a couple more examples and we'll go back to the whiteboard. Okay, so now we've got three more equations. And this is using pure elimination. And if you notice, there's a plus z's and minus z's. So I can get some to eliminate all the way out. First thing I'm going to do is combine these two. So I just add them together. My z's will cancel out. I get 3x plus 2y equals 15. Now I'm going to take equations 1 and 3 because that gives me a plus z and a minus z. It's important anytime you do this that you eliminate the same variable. I guess the y's will eliminate too here, but don't go seeking to eliminate the y's. Make sure that your z's will eliminate. So I get 6x equals the y's and the z's both cancel out, and I get just 18. We'll get an example next where it doesn't. I'll divide by 6, and I get x equals 3. I can now take this equation, plug in 3 for x, and solve for y. 3 times 3 is 9, so I'll subtract 9 from both sides. So yes, I did just do 3 times 3, and now I'm subtracting it. 2y equals 6. Divide by 2. Y also happens to equal 3. I can pick any equation for the top and plug in x and y now that I know both of them. I'm choosing the first equation. I don't know why I just did y. I'm plugging in my values. 2 times 3 is 6. 6 minus 3 is 3. Now I'm subtracting 3 from both sides. Z equals 1. My answer, again, x, y, z. 3. It's an ordered triple. It's just like an ordered pair, but it's for 3 dimensions. That one wasn't so bad. This one's probably going to be worse. So again, I've got 3 equations. Oops. And I'm looking at this going, what do I want to eliminate? I think I'm going to choose x. And I'm going to start with equations 1 and 3. Because x will just eliminate there. When I add them together, I get negative y plus 3z equals 13. I have to then choose 2 other equations, and I need to make sure I eliminate x. So I'm going to multiply equation 1 by negative 2. I could multiply by negative 1 and eliminate a y, but that doesn't help me. Oops. So I'm multiplying here, and I'm actually just distributing right across the equal sign here. Yes, you can write that in a single set of parentheses. So that's my transformed equation 1. Now I'll write equation 2 underneath it. I'm going to multiply all of this by negative 1 and combine it with my other red equation here. So if I multiply it by negative 1, things will eliminate. when I add. I'm adding these two. 4z equals 12. When I divide by 4, I get z equals 3. Okay? Now I'll plug back in either one of these equations. I just happen to like y plus z. I'm taking this equation here. Equals -1. I plugged in. Subtract 3 from both sides. I get y equals -4. I'll take any one of my equations. This one looks good. I like that one because x is just by itself. Plug in for y and for z. -4 plus 2 times 3, that's 6. So x plus 2 equals 3. X is equal to 1. My answer is 1, -4, 3. It is a process. It gets to be a bit of a mess. The keys to this elimination are pick two equations, eliminate a variable. Pick another combination of two equations, not the same one, and eliminate the same variable. So you get to these two equations with two unknowns. Then you just do elimination like you've been doing. Again, eliminate a variable. I guess I multiplied by -1 to get to there, which multiply gets stuff to eliminate. Solve for the single variable. Use one of those two variable equations to get your second variable. Then substitute into one of your original equations to get your third variable. And finally, write your answer.